All right, here we go. Little study guide showing you how to do, I believe, these 2022 problems. But here we go. First problem here, doing a sequence. I got step one. I have 3 dots. Let's do that in blue. Step one, 3. When I go to step two, count them up. I got 1, 2, 3, 4, 5, 6. Going, looks like I'm going up by 3. Step number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, looks like I'm going up by 3 each time. Step 4, looks like I have 12. All right, once you have that, this adding number, this adding 3, that is my common difference. That's my common difference number. That's 3. I could use that to backtrack to find that 0 term. So 3 opposite of adding 3 gives me the y-intercept, which is 0. Looks like this one is proportional. So if I wanted to write an equation, let's see how many steps at number 9. I could either use recursive to get to the 9th step here. So I go 4, 5, 6, 7, 8, 9. I could use recursive. 12 plus 3 gives me 15. 15 plus 3 gives me 18. 18 plus 3, 21. 21 plus 3, 24. 24 plus 3 gives me that answer, 27. How many dots after step 9? There are 27. And I used the recursive. Here it is. This is the equation I used. F of x equals f of x minus 1 plus that 3 number I'm adding each time. So to find each term, use the one before it, add 3. To write explicit, I could either use the 0 term, the way we write it, the 0 term one would be that slope number 3, 3 times that x plus the y-intercept number. So pretty much f of x at that 0 term is 3x plus 0, or just plain old 3x. That is the main recursive one that we use. If I'm using first term explicit, remember first term would be 3 times that x minus 1 plus that y-intercept, not that y term, which is 1. And again, no, these are the same, even though these look different, even though one function is just 3x and the other one is 3 times x minus 1 plus 3. Remember, these are equivalent. These are equivalent. If I was to distribute this, that gives me 3x minus 3, and then plus in that 3 just gives me 3x. They're equivalent. So explicit, I'm going to use either a 0 term, f of x equals 3x, or the first term, f of x equals that 3 times x minus 1 plus 3. And how many dots at the 0 step? I could see 0 dots. 0 dots. All right, so I'd like you to try one, lady. Try one right here, where step 1 has 2 dots. Step 2 has 1, 2, 3, 4, 5, 6 dots. Looks like I'm going up by 4. Step 3 should have 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Try that one. Try to see how many dots at 9. Try to write all those equations. I will help you. Try to find how many dots at 0. Try this extra one. All right, keep going. This one, solving these inequalities. Take away this 4 on both sides. Make sure to bring down this negative 2x. That gives me more than or equal to positive 2. And then right there, dividing by negative 2 is the step that's going to make that inequality switch. So it's not going to be more than anymore. When I divide both sides by negative 2, now it switches to less than or equal to, and this should give you negative 1. Try one. Negative 3x plus 2 less than 14. Try that one. All right, going over here. This one, take away 2. Take away 2 gives me negative 1/5 x more than or equal to 10. Know that the opposite of timesing by negative 1/5 is timesing by the reciprocal, which is really timesing by negative 5. That's what I'm doing. But that timesing by negative 5 will make this inequality switch to less than, and then this should be negative 50 if you solve that one correctly. Try negative 1/2 x plus 3 is starting out as less than, and let's make this 8. All right, keep going. On this, graph it and then identify the x and y intercept. So starting at 4 on the y-axis, that is my y-intercept, that 4. And then that slope number looks like I'm going to put that negative up on top with that 2. Looks like every time I go right 5, I go down 2. Right 5 boxes. 1, 2, 3, 4, 5. Down 2. Down 2. Keep going. 1, 2, 3, 4, 5. Down 2. And it looks like my graph here, even though it doesn't show it, looks like that is the dot where I get my what's called x-intercept right there. So if I look at that, if I get that line proper, this is my x-intercept right here. Looks like that would be at 9, 10. Looks like that is the point 10, comma 0. Know that for the x-intercept, y is always 0. And this y-intercept up here is 0, 4. Know that for a y-intercept, x is always 0. X is always 0. All right, so try y equals negative 2/3 x plus plus 4. Try that one. All right, keep going. This one here, 2, 8, 32. Looks like I'm going up by 6, or no, looks like I'm timesing by 4. Ooh, timesing by 4, timesing by 4. That makes this exponential. That makes this a geometric sequence. If the first term is 1, then they want explicit. So 1, 2, 2, 8, 32, I'm sorry, 3, 32. If you're using that first term here, the R number is timesing by 4. Let's put that up here, timesing by 4. That's my R number. So if I'm using first term, that would be f of x equals that first term there, which is 2, times that R number raised to the x minus 1 power. That's if I'm using the first term right here. First term is 2. And to prove it, plug in 2, see if 2 works. 2, does 2 work? 2 times 4 times 2 minus 1, that gives me 2 times 4 the first. 2 times 4, does that give me 8? It sure does. If I wanted the 0 term, I would have to do the opposite. I would be timesing by 1/4, taking this 2 times 1/4. 2 times 1/4 gives me 2/4, which is 1/2. So the 0 term is really 1/2, and that makes sense because 1/2 times 4 is 2. So the first term, there it is, the 0 term would be f of x equals that 1/2 times 4 to the x power, and I'm not sure which one he's having you use, but I know both those will work money. Either the 0 term, 2 times the number you're raising to that power, 4 to the x minus 1, or using f of x equals 1/2 times 4 to the x. Both those will work. All right, next one, sequence 1, 4, 7. Looks like 1 is 1, 2 is 4, 3 is 7, 4 is 10. Looks like I'm adding by 3 each time, adding by 3, adding by 3. I'm going to use the 0 term explicit, take away 3 gives me 1 minus 3 is negative 2. So this one looks arithmetic. I'm going to use the generic form, which is 3x minus 2. I'm going to use that equation to plug in 10. And if you don't believe me, see if that works. Plug in 2 right there. 3 times 2 minus 2, is that 4? Yes, it is. That equation works. So now plug in 10 into that equation, see what you get. 3 times 10 minus 2 gives me 30 minus 2 gives me the 10th term is 28 for that one right there. All right, this one, simplify. All they want you to do is distribute and combine like terms. Distribute. So that gives me 6 minus 3x plus 3. And then just combine those two. So that should give me f of x equals negative 3x plus 9. Wanting to see that. That is the first term there. That is the same answer as the 0 term one. All right, keep rolling. Number 7, solve this equation. I'm going to start by timesing by 3. Makes these cancel away. Bring down that 2x plus 4 that's left. This gives me 24. Take away 4 on both sides. That gives me 2x equals 20. I believe. Divide by 2. And that should give you x equals 10. You could always check it, plug that 10 in there for x and see if that timesing and dividing by 3, see if that gives you that 8 over there. Yep, 24 divided by 3 is 8, so I know that answer works. All right, next one, distribute. Distribute. That gives me negative 6x minus 2 equals 10 minus 5x, and then it's a variables on both sides equation. Start by adding 2, negative 3x, adding 2. We'll make these go away. Bring that negative 6x down, bring that 12 down, bring that negative 5x down. Stay on that side and add that 5x to both sides. That negative 6 plus 1 gives me, or plus 5 gives me negative 1x. And right there, that's not fully solved. Divide by negative 1. And that gives me x equals negative 12. All right, moving on. This one. Start by adding this 2. That gives me y over 3 equals negative 5. And then right there, times by 3. And that gives me y equals negative 15. All right, keep moving. This one, the domain is measured left to right through my x numbers. So it looks like negative 1, 2, 3. Looks like I'm going from negative 3. And I could use it in notation like this all the way to 2. Or if I want to use inequalities from 3 to 2. That's where all my numbers are going, from this negative 3 to that 2. That's my domain. My range, looking at my y numbers from negative 2 up to 3, from bottom to top. So that would be from negative 2, comma 3. Or if I'm using inequalities, negative 2, put a y right there instead of an x, and that 3. All right, intervals where it's going uphill. Looks like right here I got to stretch from negative 3 to negative 1. And then I can use inequalities, of course. Looks like where it's another set where it's going up, looks like from 1 to 2. I can write that in set notation too. All right, decreasing intervals, looks like this stretch right here, looks like there's only one stretch going downhill from this negative 1 on the x-axis to 2. downhill, square brackets, or with inequalities. All right, the maximum, this spot right here, written as a coordinate, looks like -1 for x, 3 for y. The minimum, this coordinate written as a rounded coordinate, looks like over 1 for x, down 2 for y. The interval where f of x is more than or equal to 0 is this line. So where it's more than or equal to 0 is this chunk of data right there. So it looks like about -2.5 to maybe, I don't even know what that is, 0.1 or something. So we'll say where it's above the x-axis from about -2.5 to right here, which you'll say 0.1 or something, I'm not sure. But where that's above, let's say -2.5 all the way to about 0.1, or if I did that interval notation, all that, and then where it's below 0 right here, looks like I got from -3 to about -2.5. Looks like that stretch is under the line, and then it looks like about 0.2 or 0.1 again. I'll use 0.1 all the way to 2 using decimals. And if I use interval notation, I want to check those. All right. Okay, let's keep going here. So, next problem. All right, it wants the domain and the range. Looks like with these arrows, I have my domain going from rounded -infinity to positive infinity. If I was to write that interval, would be -infinity, got your x, got your other infinity. For my range, looks like I got from -infinity going down up to this 3 up here, square bracket. That would be from -infinity, y less than or equal to that 3, I believe. Interval where it's increasing looks like from -infinity all the way up there to 0 on the x-axis, or from -infinity, got your x less than or equal to 0. Where it's decreasing looks like I got from 0 to positive infinity, a square bracket 0, positive infinity going to the right. Even though that arrow is going down, that interval is going from left to right. 0 less than or equal to x less than infinity, I believe. Maximum looks like that point right there is 0, 3 is the maximum. Minimum, there is no minimum. There is none. Interval where the line is above 0, on or above 0, looks like from about -1.5 to 1.5, I'll say. So from square bracket -1.5 to 1.5, where that data is above that line. And maybe write it like this, interval notation. Intervals where it's below underneath, so it looks like from -infinity to here, and then from +1.5 to +infinity. So it looks like the two intervals where it's under -infinity all the way there to about -1.5, and my other one from +1.5 to +infinity, because it's going to the right. And if I did that in inequalities, and this one inequalities. All right, let's move on. Come on in. right, here we go. Moving on. This one, it says plug in -4 right here. So I got f of -4 equals -3 times that -4 plus 8 gives me the function when x is -4 gives me 12 plus 8. Looks like the function when x is -4 gets spit out as y as +20. All right, this one, easy. Where is that solution? That solution, looking at this graph here, it's going over not 2, over 4 on the x-axis, and not up 1, up 2. That point is 4, 2, over 4, up 2. It looks like it's 2, 1, but look at the graph. Look at scale going by 2s. All right, moving on. This guy right here, domain are all the x coordinates. These are coordinates. This is the coordinate 1, 20,000. All the x numbers are their domain. So 1, 2, 3, 4. Those are my domain. The range are all these numbers. 20,000 I got. 20,000, 40,000, 60,000, 80,000. That is my range. The y numbers. All right, moving on. Graph in this one, looks like they want you to solve this for y first. So I'm going to take away that 5x on both sides. That will give me 3y equals -5x plus 30. Right there, divide everything by that 3, divide by 3, divide by 3, divide by 3. That makes this y by itself -5/3 x over 3 down 5 plus 10. So it looks like I'm starting at +10 on my y-axis. And looks like every time I go right 3, I'm going down 5. 1, 2, 3. 1, 2, 3, 4, 5. So right 3, down 5. 1, 2, 3, down 5. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Looks like touches the y-axis right there and x-axis. Try to draw that line best I can. And again, this right here, this is the x-axis when x has y coordinate always 0, and then the y-intercept where the y has the x coordinate always be 0. Know that. For that y-intercept, x is always 0. For the x-intercept, y is always 0. All right, moving on. Solving these. Here we go. This one has me distribute. So I'm distributing twice. Gives me 3x minus 6 less than 3x minus 4 plus 4x. I'm going to combine like terms over there. Combine that 3x and that positive 4x. That gives me 3x minus 6 less than 7x minus 4. I'm going to add this 6 to both sides. And then I'm going to subtract 7x. That gives me plus 2. Stay on this side, subtract 7x. That will give me -4 of those x's. And then right here, divide by -4 is going to take that inequality and flip it around. So it's now not x is less than, it's now more than. And then that is -1/2 reduced. That's not -2. All right, next one. Here we go. Hopefully got that one right. This one I'm distributing. Looks like both. That one's going to give me -6x minus 2 more than or equal to 12 minus 6x. Stay on this side. Add this 2 to both sides. That will give me -6x more than or equal to 14 Then right there, I'm going to add 6x to both sides. And that gives me 0 more than or 14. That's a false statement. So I believe this one has no solutions. If I would have got two equal numbers, I believe something like that, that would have been a many or infinite solution one. All right, next one, here we go. They want you to plug in plug in P. P is 4 days. So they want you to plug in P is 4 right here. So here I go. The cost after 4 days is 5 times that 4 plugged in right there, plus that 10 tells me the cost after 4 days is 20 plus 10. The cost after 4 days is 30. That's what that is. After 4 days, the cost is $30. That's what that's asking right there. All right, moving on. 19, this one says describe in words. So I got f of x. So just remember, anything like this, f of x and a number, this is your x spot, this is your y number right there. So this one telling me 5 here, f of x describes a person's height in inches depending on their years. So it looks like I'm plugging in 5 years. Someone who's 5 years is 40 inches tall. That's what this is saying. So that 5 right there represents years, represents X. That 40 represents after 5 years, how many inches. This F of 10 represents 10 years. The person's height after 10 years. This one right here, you don't know how the age, but you do have the height. The height is 65 inches. So this is, you know the height of the person, but you don't know what their age was or how many years. The middle one, you know that that person is 10 years, but you don't know their height. And then that top one gives you both the X and the Y. That's kind of what these problems are for. That top one's giving you the X number of years. Y is the number of inches. That B1 is giving you the number of years, and that middle one's giving you just the number of years, but you don't know the, it's giving you inches, but it doesn't give you the years. And then that last one gives you the, I got that backwards. Looks like this one is telling me that I know it's 10 years, but I don't quite know the height. And then this one is telling me I know the height is 65 inches, but I don't quite know how many years that person was. All right, so hopefully that's okay. 20, here we go. This says, describe the domain and range of this function in words. So it looks like my X, my range, my domain are the X numbers. My H of X, my Y, these are my range. So I don't know if it wants you to write the equation or whatever, but it looks like domain goes from 10 to 50. That is my domain. Looks like my range goes from 1 up to 5. For this one, you would be trying to find the change in the Y number. This is going up by 1, while my X number is going up by 10. All right, so again, I'm not sure what he wants you to do other than describe that. The X numbers, those are my domain. It goes 10, 20, 30, 40. Those aren't the Y numbers. H of X, those, oh, I'm sorry, I think I do have this backwards. It looks like the way this is written, the H of X, I think that's right. I think X, are the numbers you're plugging in. If you're plugging in x is 10, that's the x number. H of x is what you get for y after you plugged it in. So pretty sure about that. Where that left column are the domain and the range are 1 through 4 or 1 through 5. All right, this one says which ones are functions. Anything that has an x number not show up more than once. 2, 6, that shows a 6 showing up twice. One spits out a 9. This one is a 1. That is not a function because of that 6 number right there. If I look at the next one, none of these x numbers are repeating. So that one is a function. And then this last one here, -5, -7, -3, -4. None of those x numbers are repeating. So that one is a function. Remember, for it to not be a function, the input is going to spit out more than one output. All right, watch this. Hopefully helps a little bit. We'll meet up and hopefully get you going for that final. Thanks for listening.